Hi everyone, just a quick video to run through the design choices and performance of my 250 watt mid-drive e-bike conversion. When designing an e-bike, the most important considerations are around how you intend to use the bike and the sort of terrain you wish to use it in. I wanted the bike to be street legal. Here in the UK, this means using a motor with a maximum output power of 250 watts. But because I live in hilly Devon, my main priority is good hill climbing ability without sacrificing too much in the way of top speed. The bike I'm converting is a Specialized hybrid, which I've owned for about 5 years. This bike was already good for the local terrain and has powerful hydraulic disc brakes, which are easily capable of managing the extra weight and speed of an e-bike. Because of my design priorities, I've chosen a Bafang BBS01 mid-drive motor. The advantage of this over the hub drive alternative is that for a mid-drive motor, the power is delivered via the bicycle transmission and gears, the latter giving the motor a much wider range of conditions over which it can effectively deliver its power. Having decided on a mid-drive motor, the next design choice is the gear ratios. These are defined by the size of the front and rear sprockets in combination with the 27-inch wheels of my bike. The Bafang motor came supplied with a 42 teeth pressed steel chainring, but I chose to replace this with an aftermarket 42 teeth Lekkie Bling ring, mostly for the lower tooth count, which gives me more mechanical advantage for hill climbing. The Lekkie Chainring also has improved chain line over the stock Bafang item and has alternating wide narrow teeth to match the profile of the chain. These features act to minimise unwanted chain derailments and unnecessary gear train wear and tear. In order for the bike to work well in the wide range of different terrains I encounter in Devon, I've fitted a wide range 11 to 46 tooth Shimano cassette to the rear wheel. This choice meant I also had to replace my rear derailleur with a large cage mechanism to accommodate the wide range cassette. 11 and 12 speed cassettes are also available, but I decided to stick with a 10 speed since more gears means a narrower chain that is more prone to wear. Given that there is 250 watts of extra power going through the chain, I didn't want to sacrifice chain life for a few extra gears. On the topic of the battery, I wanted to have the possibility of long cycle rides, so I decided to go for a 19.2 ampere hour option. Bigger batteries are available, although 19.2 ampere hours is at the upper end of what most people are using. The trade-off here is mostly about cost. If you don't need the extra range, you'll save money by going for a smaller battery. There are various basic options that can be set from the LCD display by entering a configuration mode, but there are far more motor options that can be set via a PC if you buy the optional Bafang controller programming lead. I would recommend doing this. Whilst the bike does work adequately well with all the default controller options, I found I was able to considerably improve the e-bike's performance and usability by changing a few of the default settings. I'll leave a link below the video to a page that describes how to do this and suggests a few useful changes to the default options. Another optional extra I'd recommend getting is the Bafang inline gear cable sensor. This device cuts part of the motor whenever a gear change is detected, ensuring the transmission system is not under full load when the chain is moving up or down the cassette. I'm not sure how well gear changes would go without the sensor. I can imagine that damage to the rear cassette might be quite likely if gear changes were made under full load. The Bafang motor comes with replacement brake levers which contain brake sensors. These make sure that power is cut to the motor the instant the brakes are applied. Because my bike has hydraulic rather than cable brakes, I was unable to make use of these, so I bought the optional hydraulic brake sensors to add to my existing brake levers. However, I could not find an easy and reliable way of attaching the sensors, so in the end I decided not to fit them. Instead, I've just set the pedal assist cutout time to a minimum by programming the motor controller as described previously. To me, this works fine. The brake sensors aren't really required. The motor does occasionally run on for half a second when I stop pedaling, but in practice, the motor is no match for the power of my rear brake. So, how does the e-bike work, and is there enough power in the small 250 watt motor to give it a decent performance? I think it actually works really well, and the wide range cassette I've chosen for the rear wheel means that in first gear the bike can haul myself as a 74 kilogram adult up some very steep hills without me having to pedal at all. At the other end of the gear range, top gear still allows a top speed of about 28 miles an hour, which is faster than I can pedal on a flat for any length of time, and even going downhill I don't often want to go much faster than this. Note that in order to comply with UK e-bike laws, the motor assist is set to cut out at 15.5 miles an hour, so any cycling above that speed happens purely by muscle power. The 250 watt motor does, however, easily provide enough power to keep the bike moving at 15.5 miles an hour, both on a flat and even up a gentle hill, with the motor doing all of the work. I find that setting the pedal assist to just 1/3 of the motor's maximum power gives me a useful boost in performance and makes uphill cycling easy on all but the steepest of hills. Using the bike like this in hilly Devon countryside with occasional boosts to higher power levels to climb particularly steep hills, the 19.2 Ah battery seems to provide about 80 miles of range. With the pedal assist set to maximum and the motor doing almost all of the work, this reduces to about 50 miles. In both cases I've calculated the range from a partial discharge. I've not yet tried running the battery completely flat to see how far it would actually take me. Note that the e-bike can still be pedalled even when the battery is flat, but with the extra weight of the battery and motor combined with a bit of extra friction in the motor's clutch system means that it's somewhat harder to pedal than a normal cycle. I would not like to ride it any great distance with a flat battery. Some people have asked me how well the wide range cassette works and whether, given the wide range, gear changes are easy and reliable. In fact, it works incredibly well. Gear changes are smooth, reliable and precise. In terms of reliability and ease of use, it is actually quite a big improvement on the 2x10 speed system originally fitted to the cycle. And the wide range cassette gives a similar spread of gear ratios to the previous 2x10 setup. So getting rid of the front derailleur has only been a good thing in my opinion. Well, that's it from me. I hope you found the video informative and thanks for watching.